Assalamualaikum, how are you, Shavi?
I'm good. Sorry for being late. My mother was in surgery. She didn't send me the email. Well, she sent me the email, but I didn't have the password and ID in my mail on my laptop wasn't working. But I have it working now.
Okay, well, it's okay, no problem. I hope you're doing great and everything is going well.
Thank you.
So, have you prepared what we did in our last lecture?
Yeah.
Okay. Have you did your home assessment?
Yes, I did.
Okay. So, when will you share with me your previous
Um,
assessments?
I have it. I can send it to you now.
Okay, so you can just make a PDF and share it to me later. Okay,
All right.
so that I will cross check. Should we? Are you ready for our today's lecture? Should we start?
Yeah.
Okay, so
Yeah.
let me share screen with you. Is it my screen is sharing?
Yeah.
Yeah, well, so today is our lecture number 3, and in today's lecture, basically we will discuss about motion graphs. There are some important graphs which is very useful to understand, to interpret, and we have to learn about those graphs. So, in our learning objectives, we will basically understand the meaning of use of motion graphs. What is basically the actual meaning for making those motion graphs? And basically, we will interpret and we will illustrate the distance time as well as the velocity time graphs. These two graphs are basically the important graphs which we have to understand how to make and how to understand those graphs. And then we have some practical calculate applications, as well as we will calculate the speed from distance time graph, and we will calculate the acceleration from velocity time graph. Basically, distance time graph is used to calculate the speed, whereas your velocity time graph is useful to calculate the acceleration. Okay,
Mhm.
so these two graphs which we have to understand in today's lecture. So let's first start with the distance time graph. Basically, a distance time graph basically shows how the distance of an object from a starting point changes over time. You already know what is distance,
Mhm.
what your body covered. Okay, so basically, distance time graph illustrates the distance which your body covers, as well as whenever your body covers some distance, they must use some sort of time. So distance over time, and you can say the distance with time graph is so called as the distance time graph. Understood?
Mhm.
Okay. So basically, distance time graph helps us you to visualize the motion. You can interpret what's the motion, what's the actual motion of the body. Either your body is at rest, either your body is at motion, either your body is moving with variable speed, either your body is moving with constant speed. So these visualizations you can visualize by just watching those graphs. Okay, and by making distance time graph, the gradient line, I will show you later what is basically actual meant by gradient, but the gradient in the graph basically gives us the value of speed. Understood?
Mhm.
Okay, so since speed is you already know what is speed. Speed is basically the rate of change of distance. Okay, and we
Yeah.
are already making graph of distance over time. So if we are making graph of distance over time, means we are able to use the speed. Okay, okay,
Mhm.
once we make the graph, you can interpret how the steeper the line, the faster the object is moving. If the line is steeper, you know what is meant by steeper.
Yeah.
Yes, so if the line is steeper, so you can say the body is moving with faster speed. If your line is not steeper, then you can say body is moving with variable speed and slow speed. Whereas
Yeah.
your curved lines, or you can say your curved graph, basically indicates that there is changing in speed. Okay.
Mm-hmm.
Okay. So now we will see some important factors which we will illustrate in the graph. First of all, in our distance time graph, we have straight line. And what does this
Mm-hmm.
straight line means? Basically, this straight line, or you can also say this is called as the upward slope. Okay. Straight
Mm-hmm.
line basically means your object is moving with constant speed. The speed is not changing. Okay.
Mm-hmm.
So you know what is meant by constant speed. Means speed is not changing. If a body is moving, let's example like a car is moving with a speed of 10 meter per second. Means at every point, at every second, the car's speed remains same, which is 10 meter per second. If the speed is not changing, you can say the speed is constant speed. So if your body is moving with constant speed, the graph line should be straight line.
Curved.
Okay? Straight line.
Oh.
Okay, straight line. If your body is moving with constant speed, then the graphs have line should be straight line. Okay, or
Mm-hmm.
you can say distance increases uniformly with respect to time. We will see in the graph, but you have to understand this before. Okay.
Mm-hmm.
Next is basically we have horizontal lines. You know what are horizontal lines? This type of lines, basically horizontal lines, these straight lines. This is vertical.
Mm-hmm.
Am I right? This standing line is called as the vertical lines, and this
Mm-hmm.
base lines is called
Yeah.
as the horizontal lines.
Mm-hmm.
Okay, so if your graph having horizontal lines, then you can say your object is stationary. Means your object is not moving. Okay.
Mm-hmm.
Okay, like you can say, if somebody person is waiting for a bus at your bus stand, means that person is just standing, not moving. So if a person is not moving, if a person is just stationary, so the graph illustrates horizontal line for them. Okay.
Mm-hmm.
Hmm. And next is basically the curved lines. Basically, which I mentioned you before, there are two types of curved lines. Either the curved line is increasing or either the curved line is decreasing. Whereas curved line increasing is concerned, it means your object is accelerating. Okay, means their speed or you can say their velocity is increasing. Am I right? Are you getting my
Yeah.
voice? Okay, so if your curved line is increasing, you can say your object is accelerating. Okay, and if you can see your curved line is decreasing, you can see this means basically your object is decreasing.
Yeah.
Okay, is my voice is clear? My voice is clear. Is my voice is clear, shall we?
Yeah.
Okay, so basically we are saying that if our curved line is basically increasing, we can say our object is increasing, and if our curved line is decreasing, we can say our object is decreasing. Okay, and we have some more steeper lines and flat lines. Steeper lines and flat line basically indicates a body is moving with high speed or low speed. As I already mentioned you before, if your line is steeper, it means body is moving with high speed, and if your line is just flat, means okay, so you can say your body is moving with slower speed. So we already discussed these points. Now let's discuss these points graphically. here is the graph of distance time graph. Are you, is it visible to you?
Yeah.
Yes, so you can say, see here, in x-axis, this is x-axis, this is vertical line, horizontal line,
Yeah.
and this is vertical line. Vertical lines are called as the y-axis, whereas the horizontal axis
Yeah.
also called as the x-axis. We always take time on x-axis because time is an independent quantity. All right?
Yeah.
And we will take distance, which is the dependent quantity. We will take distance on y-axis because distance depends upon time. Distance is dependent, whereas time is independent. We are making graph of distance time, so distance on y-axis and time on x-axis. So there are
Mm-hmm.
some graphs. So here you can see the blue line. Can you
Mm-hmm.
tell me this blue line basically represents which type of speed? What we discussed
Constant speed.
here? Yes, constant speed. So as you can see what we discussed in the constant speed here, object is moving at constant speed if we have straight line, or you can say upward slope. This is
Mm.
slope which is upward and this is a straight line. So we can say the body is moving with constant speed. The speed is not changing. How we can check the speed is not changing? Uh, you know what is the formula of speed? Can you tell me what is the formula for speed?
Uh, Distance over time.
Yes, distance over time. So, where is my marker? Can you calculate the value of speed?
Uh, 10 meters per second.
Yes, how you calculate it?
Uh, the distance is 20 and the time is 2.
Yes,
20
you're
divided by
right.
2.
So here the answer is 10 meter per second. So now can you calculate here at this point?
Uh, 10 meters per second.
Yes, again 10 meter per second. So can you calculate at this point?
10 meters per second as well.
Again 10 meter per second. So is speed's value changes?
No,
No,
it
it's
doesn't.
always remains 10. So if always the speed's value remains 10, so it means this line represents constant speed. Am I right?
Yeah.
Yes. So this upward slope basically indicates the constant speed. And can you tell me this red line basically shows the body is, you can see time is changing. 2 seconds, here 4 seconds, here 6 seconds. But the only thing is not changing. Let's suppose here the value is 30. Is distance is
Mhm.
changing?
Yeah.
Is distance is
No,
changing? No.
no, it isn't changing.
Yes, distance is not changing. So if distance is not changing, means body is at rest position or standing still.
Mm-hmm.
Yes. So if a body is standing still, if a body do not change their position with respect to time, so we can say this type of speed is called as the stationary speed.
Stationary.
Yes, you're right. And here you can see the green line. Can you tell me what this green line indicates?
The curved lines.
Yes, curved line. And there are two types of curved line which we discussed, either increasing or decreasing. So which type of this is?
Increasing.
Yes, increasing curve. And increasing curve line is also known as, we will see, also known as accelerating or
Uh,
deaccelerating.
Accelerating.
Yes, accelerating. If your curve line is increasing, we can say the speed is accelerating, means body is moving faster. If same line is decreasing, means curved line is downward direction, then you can say your speed is deaccelerating, means your acceleration is negative or your speed is decreasing. Understood?
Mm-hmm.
Okay. Any question from distance time graph?
No.
Okay. So now let's move on towards our next topic, which is the velocity time graph. Similar things which we discuss in the distance time graph. Similar with we have to do in the velocity time graph. Just distance now changes by time. Okay, time remains
Mm-hmm.
same on x-axis. Only on y-axis now distance is changed by velocity. And you know that velocity divided by time is called as,
Uh, Speed or acceleration.
yes, acceleration. Distance divided by time is called speed, whereas your velocity divided by time is called,
Acceleration.
yes, acceleration. You're right. So if velocity time graphs tells us about the value of speed, can you tell me velocity time graphs gives us the value for?
Time or acceleration.
Yes, acceleration. Because you can see distance time graphs gives us the value of speed, which is the
Mm-hmm.
formula for speed. Similarly, velocity time graphs, which is the formula for acceleration, actually gives the value of acceleration.
Oh.
So here you can see a velocity time graph basically shows how your object's velocity change with respect to time. You can see, you know that body always changes their velocity. Let's suppose if a car is moving, if a car velocity remains same, then you can say the velocity constant velocity, which we discussed in the types of velocity in our previous lecture. Okay. So if velocity
Mm-hmm.
changes with respect to time, you can say we will illustrate by using the velocity time graphs. Velocity time graphs basically useful for analyzing both acceleration and the distance of an object. Okay,
Mm-hmm.
velocity time graphs help us to analyze both acceleration as well as distance of an object. Rather. Okay, and again the gradient. In gradient, basically, let me show what is meant by gradient. Here you calculated the value of speed. How?
Distance over time.
Yes, distance over time means y-axis divided by x-axis. Am I right?
Yeah.
So basically, gradient is this. Just dividing your y-axis with respect to x-axis, it is called as the gradient. Is it okay?
Mm-hmm.
Wonderful. So as you calculate the gradient here, the gradient tells us the value of speed. Whenever you calculate the gradient for velocity time graphs, they gives us the value for
Acceleration.
acceleration. Same, you have to divide your y-axis, which is velocity, and on x-axis, which is time. So you divide velocity over time, they gives you the acceleration. Is the point clear?
Mm-hmm.
Okay. So here the gradient is the acceleration, and you know what is acceleration? Acceleration is the rate of change of velocity
Mm-hmm.
or velocity over time. You can say, okay. And
Mm-hmm.
in this velocity time graph, an important thing is that you can also calculate the distance. Okay. There are two
Mm-hmm.
things which we calculate in the velocity time graph, which I showed you here. One is you can calculate the acceleration by taking the gradient, and the other thing is you can calculate the distance. How you can calculate the distance? The graph which you make and the area under the graph basically tells us you the total distance. Okay,
Mm-hmm.
we will make the graph and like this. Let's suppose this is a graph and this is the ending point, and we make a dotted line towards downward, and this all area under this curve basically gives the value for distance. Okay,
Mm-hmm.
now the key parameters which we discussed for distance time, now we will see the same for velocity time. If the line is straight or upward slope, you can say the body has a constant
Constant.
acceleration. Like before, constant speed, in this scenario is the constant acceleration if your line is straight and upward slope. And if there is a horizontal line, this type of line, which we see here, like a red line, this is horizontal line. So if the horizontal line in velocity time graph, then you can see the body's velocity is
Uh,
constant.
Constant.
Okay, means velocity is not changing. The body has constant velocity. Like if a body Let's suppose if a car is moving with a speed of 10 meter per second, at every second, at every point, their speed remains 10. So we can say basically this gives you the constant velocity. And again, if the slope is downward, this means deceleration. Okay. You know what is deceleration? You know what is
Mhm.
deceleration?
Yeah.
Yes. If a velocity is decreasing. Am I right?
Yeah.
Okay, perfect. So if a velocity is decreasing, or you can see a downward slope, you can say this line indicates the deceleration.
Mhm.
And if some lines touches each other, the time axis, you can say. If your line just touches the time axis, means if your line is just here on the time axis,
Mhm.
so this will indicates basically your object comes at rest, means your object just stops, because at this line, can you tell me for this graph at this line what is the value of distance?
The
At this line, what is the value of distance? You can
well,
say
I don't.
0.
Oh.
This is the starting point, right?
Mhm.
Wonderful. So at this line, the value of distance is 0. And whenever we are making graph for velocity time graph, here is then velocity. And when we are on this line, then we can say the velocity is
0.
0. So if somebody has velocity 0, it means body is at rest position,
0.
or body just stops, not moving.
Mhm.
Okay. So if line touches the time axis, you can basically this indicates the object has comes to stop or comes to rest.
Mhm.
Now let's visualize with this velocity time graph. Here again you can see on x-axis. Now we will take the velocity, because velocity we know that is a dependent quantity. Every dependent quantity is always takes on y-axis.
Mhm.
And we also know what is the unit of velocity,
Meters per second.
meter per second. And on x-axis we will take the time, because time is an independent quantity. Time not depends on any other, it is an independent quantity, and we can measure time in seconds.
Mhm.
So can you tell me this blue line basically indicates the which type of
Constant.
acceleration?
Constant.
Yes, constant acceleration, because you can see this is a straight line or this is an upward slope. This. So this basically means constant acceleration. You can also check. Uh, okay, so this type of acceleration, we can say this is the constant acceleration. Okay,
Mhm.
and can you tell me this red dotted line basically indicates the
Constant velocity.
constant velocity? Yes, because you can see at this line, what is the value of velocity?
20 meters per
20.
second.
Yes, here is 20. Again, at 2 seconds, again 20 meter per second. And at 4 seconds, again 20 meter per second. So the value of velocity is not changing at every time. So we can say this type of velocity is called constant velocity. Okay. Here blue line, you can say the value of velocity is changing.
Mhm.
Changing. At 2 seconds, it's 8. At 4, it's 16. At 6, it's about 24. So
Mhm.
on this blue line, the value of velocity is changing and time is also changing. So that's why you can say this is an acceleration, because you know if your velocity is changing with respect to time, this means this is the definition for acceleration. The change in
Mhm.
velocity with respect to time is called acceleration. As here, whole line velocity is changing with respect to time, that's why this is acceleration. And because this is a steeper line and straight line, that's why this is a constant acceleration. But at this red line, basically velocity is not changing, the velocity is remains same, which is 20 meter per second. That's why we can say this is constant velocity. Whereas
Mm.
this green line, can you tell me what this indicates?
Deacceleration.
Yes, deceleration. Again, you can see the value of velocity is changing at every point. At 2 seconds, this is, let's suppose, 17. At 4, the value decreases up to 8. At 6, your value decreases up to
Zero.
0. So your velocity is decreasing at every point. Means your velocity is changing. And if your velocity is changing but decreasing, that's why you can say this is a deceleration. Okay.
Mm-hmm.
So this is how you can interpret different lines, visualize those lines, and interpret the velocity time graphs. And you can easily calculate the value of acceleration as well as the value for distance from these graphs. Okay.
Mm-hmm.
If someone asks you to find the distance covered by this blue line, how you can
Mm-hmm.
calculate the distance covered by this. So you can, what
Uh,
you have to do at the ending point, you just drop your lines straight below, okay,
mm-hmm.
and shade the area. This all area under the curve basically indicates the total distance covered by the body. All right.
Mm-hmm.
Okay. So any question related to velocity time graph?
No.
Wonderful. Okay. Now move on towards the worked example. So let's suppose if your car travels a distance of 100 meters in 20 seconds. Can you calculate the speed?
Mm,
Distance is given, time is also given. They're asking you to find the value of speed.
5 meters per second.
Yes, just divide your distance, which is 100, over time, which is 20, you will get your speed. And the unit of speed is similar to the velocity, which is meter per second. And
Mm-hmm.
again, they're asking you to draw the graph as well. This means they're asking you to draw the distance time graph. On
Mm-hmm.
x-axis, you can make the time. On y-axis, you can illustrate the distance and how you can draw the graph. Basically, you will need the values for initial. These values are basically giving you the final values. Means a car travels 100 meters distance. This is the total distance what the car travels. Can you tell me what should be the initial distance where the car just
Uh,
started traveling? Zero.
Zero.
Everybody starts from zero, right?
Mm-hmm.
Again, the car takes 20 seconds to reach this distance. Again, at the starting point, the time should be
Zero.
zero. So initial time and distance is here. First point basically indicates the x-axis. Okay, this is
Mm-hmm.
x-axis, and the second after comma basically indicates the y-axis. This is the initial data, and this is the final data. Final data is
Mm-hmm.
given. Initial data you have to interpret by yourself, and you know everybody initial position starting from zero. Time should be zero, and distances also should be zero. And as
Mm-hmm.
I told you before, the this is x-axis. First point is x-axis. On x-axis there is time. So initial time is zero.
Zero.
And the second point is y-axis, and again on y-axis there is distance, and again initial distance is zero.
Zero.
Now again this is final data. On x-axis should be time. What is the final time? 20
20
seconds.
seconds.
And the second point basically illustrates the
Distance.
distance, and the total distance your body covered is
100 meters.
100 meters. Okay, so this is how you can see. So you have to draw a line from 0 0 to this. Okay, how
Aye.
you can draw your line? 0 0 point is here, Am I right?
Mm-hmm.
Distance is 0 and time is also 0 at this point, right?
Mm-hmm.
And second point is this. Time is 20 and distance should be 100. So this point, right?
Yeah.
So this is a point and this is a point. So you got 2 points. What you have to do, you just have to make a straight line.
Mm-hmm.
So basically this line, how you can draw from distance time graph. And can you tell me this line basically interprets which type of speed, constant or not?
Constant. Yeah.
Yes, constant speed. So this is how you can make graphs from this type of data. Understood?
Mm-hmm.
Okay. Can we move next?
Sorry.
Uh, can we move towards next topic?
Yeah.
Okay. Now here is another work example. Now it's from velocity time graph. Okay.
Mm-hmm.
Same, they are asking that a bus is accelerating from 0 to 20 meter per second. Now initial data is already given. Okay. Initial velocity is 0 and final velocity is 20 meter
20.
per second. And again in 10 seconds means this is the final time,
Uh,
right? And what
mm-hmm.
should be the initial time? 0.
0.
Okay. And they are asking you to find the acceleration. The
Mm-hmm.
velocity is given and time is
Mm-hmm.
given. They are asking you to find acceleration. How you can find acceleration? You know the formula of acceleration. Final velocity minus initial velocity over time. So final
Mm-hmm.
velocity is 20, initial is 0, our time which is 10 seconds. So 20 minus 0 divided by 10, which is 2 meter per second square, right?
Mm-hmm.
Yes. And they're also asking you to make a graph. How you can make a graph from this? Again, you can see initial data is 0, 0, right? So that's why your
Mm-hmm.
point is here.
Mm-hmm.
Time is 0, velocity is 0, initial data. And final data is this. Time is 10 seconds and your velocity is 20 meter per
20.
second. So here you can go up to 10 and here you can go up to 20. The point is this, so you can draw a point here. So this is a point, this is a point. What you have to do, just mark a straight line till here, right?
Mm-hmm.
Again, can you tell me this straight line shows which type of?
Constant acceleration.
Yes,
Um,
constant acceleration, right? So this is how you can make the velocity time graph. They're also asking you to find the distance that your body covers. As I mentioned you before, how you can calculate the distance.
mm-hmm.
What you have to do at the ending point, you just make a straight line below. If I
Mm-hmm.
make a straight line below, okay, here you can see if I make a straight line below, which type of shape is this?
Uh, Triangle.
A triangle, yes, a triangle, okay. So how you can calculate the area of triangle. Do you know the formula of area of triangle? 1 by 2 base into height?
Yeah.
Yes, you can write the formula for area of triangle. The formula for area of triangle is 1 by 2 base multiplied by height. This is called as the base on
Mm-hmm.
y-axis and this is the height. So what is the value of base from here to here? It's 10
Uh,
total
10.
from 0 to 10. What is the total value is?
10.
10. And what is the value of this height from this point to this point is maximum value is 20.
20.
So you have to do multiply 10 multiply by 20. So here you can see if you want to find the distance or area under the curve, which will give you the value of distance, you have, because this shape is a triangle, you have to use a formula for triangle. The formula for triangle is 1 by 2 base into height. Base is 10 and height is
20.
20. So 10 multiplied by 20. Okay, so this is how you can calculate. Okay,
Mm-hmm.
200 and 200 divided by 2, it's become 100
Mm-hmm.
meters. So this is how you can find the distance as well as acceleration by using the velocity time graphs. Okay, so here's a quick quiz for you. So can you tell me what does the gradient of distance time graph represents?
Uh, the speed or
Yes,
distance.
yes, you're right. The distance time graph represents the speed. In
Mm-hmm.
distance time graph, the gradient is basically the speed. And can you tell me what does the area under a velocity time graph represents?
The distance.
Yes, you're right, the distance. Okay, let's see. And here is a question. A runner moves at 5 meters per second for 6 seconds. Sketch the velocity time graph. Can you make a velocity time graph if a runner moves at the same velocity? So you can see the velocity is changing or not? No,
No.
the velocity remains same for each 6 seconds. So if a runner moves at 5 meter per second velocity for 6 seconds, sketch their velocity time graph. How you can make? First of all, you can take time on x-axis. Maximum time is
Mm-hmm.
6 seconds. So you can take values up to 6. And
So,
maximum velocity
uh,
is 5. You can take up to 5 or 6. Okay. And if velocity is not changing, so you
mm-hmm.
can make a straight line up to 6.
So,
Why 6? Because time it takes 6 seconds. All right.
mm-hmm.
So
Yeah.
you can just make a graph from this data. Understood? Can you make this?
Yeah.
Okay. All set. Any question?
No.
Okay. Now here is some homework assessment for you. Just 3 questions. Now
Mm-hmm.
here it's your assessment. You can solve these questions till your next class on next Sunday, inshallah.
All right.
Okay. So these are
Okay.
some easy questions. You have to draw and label a distance time graph for a car which is at rest. Rest
Mm-hmm.
basically means they start
It's
from
stopped.
zero. They're starting from zero. Okay. For 10 seconds. Again, you have to take time, initial time zero, and also you have to take initial distance is zero. Okay. And you have
Mm-hmm.
to draw a distance time graph for constant speed. You know how to make a distance time graph for constant speed. Okay.
Yeah.
And in second question, you have basically a cyclist increases speed. Increases speed from 0 to 15 meter per second in 5
Mm-hmm.
seconds. You just have to calculate the acceleration. No need to illustrate the graph in this question. You just have to find the acceleration. You know what how you can find.
Yeah.
Velocities are given and time is given. Initial velocity is given, final velocity is given, and time is given. You can easily calculate the value of acceleration. And if
Mm-hmm.
the acceleration is positive, you can say this is
Positive
positive
acceleration.
acceleration. And if your answer is negative, you can say
Negative acceleration.
yes, negative acceleration. And in third question, what you have to do, use the graph below attached in printed version to calculate the distance time total cover. The same, okay, what you draw in first question, you have to
Mm-hmm.
calculate the distance covered. Okay,
Okay.
okay.
Mm-hmm. Yep.
Or this is basically distance time graph, but here they are asking you to find the this, okay,
Distance.
total area under the curve. So any question?
No.
So if no question, just wrap up this section. Thank you for
Okay.
today's class.
Sorry.
Thank you for today's class.
No worries. Thank you as well.
Take care. Allah Hafiz.
In the office.
This PDF is attached. Okay, I will also share with you.
All right. Okay. Thank
Thank
you. Right.
you. Allah Hafiz.
Right. Bye. No office.